Okay, for this section, we are going to talk about quadratic functions. I know that they have come up a little bit in the past when we talked in section 1.5. We are going to be looking more today at graphing and applications with this, or in these next few sections, videos that we do. More about applications of them, how the different formats that they can come at, and things of that nature. So the first thing is that graphs of quadratics do have an axis of symmetry, and they have a vertex that could be a maximum or a minimum. Okay, so let me first off show you. So a quadratic graph is a U-shaped graph, so it's a parabola. This is called a parabola, and they can either go kind of in a bowl shape like this, or they can be in a hill shape like this. Now then, this axis of symmetry cuts through the graph exactly in half so that it is a mirror image of itself on the left and the right side when we're talking about traditional parabolas based in y equals and then the format that we have. Now, the vertex is where the axis of symmetry crosses through the actual parabola graph. Now, this vertex here is a minimum if A is greater than 0. And this is when we're talking about, we've seen the format before, that ax squared plus bx plus c format. So if A is greater than 0, then the parabola opens upwards, and we have that this vertex is a minimum. Here, the vertex is a maximum, and that occurs when A is less than 0 or when A is negative, okay? So if A is positive, then it opens up. If A is negative, then it opens downwards, okay? So now, when we're graphing a quadratic, one of the first forms that we talk about or we discuss is what's called standard form. Now, in standard form, you're going to be able to tell how this graph moves as far as left, right, up and down, flipped over, that type of stuff. So our standard form is f of x equals a, and then parentheses x minus h squared plus k. Now, that x minus h squared should look familiar from when we did circles. And that is still the format that we're working with. That, when we did this with circles, talked about our left and our right movement. And it still does that. And it's still in the parentheses, which means it's still doing the opposite of what we think. So plus is actually to the left and minus is actually to the right. Now, the difference with our quadratics in their standard form is that we do not have that y minus k squared or that y minus k in a set of parentheses like we did with the circles. So this just has plus k. It is not in a set of parentheses. So that means that this plus k, it is going to handle our up and our down, but it is going to do exactly what we think it's supposed to. So plus is going to go up and minus is going to go down. Now, the information that we're going to get from here is that our vertex, A, our vertex always starts at 0, 0, and then it will move left, right, up, down, however we need it to move. If A is positive, then it opens up. If A is negative, then it's going to open down. That stays the same. Okay. Now, the steps for graphing a quadratic in its standard form. The first thing that I want to know is whether or not it opens up or down. Okay. And this is more so for when we actually start to put points on graph, that if we say our graph is supposed to open upwards and it looks like I've got dots that are making a hilltop shape, I probably did something wrong. Okay. So it's just a way for us to check ourselves. Then the next thing I want to know is where's my vertex? So I want to talk about how does this thing move left, right, up, down? What does it do so that I can figure out where that vertex is going to be? For our x-intercepts, we are going to set the function equal to 0 and solve. This is going to be one where we've got a little bit of math stuff that we've got to do. The y-intercept, we're going to plug in 0 for x and solve. We saw this similar process done when we were solving linear equations and using an intercepts method. And then we're going to plot and graph. So plot is just the putting the dots on the page. Graphing is actually going to be connecting them. Okay. So the example that we're going to look at, I've already put over here on my board. We're going to look at negative parentheses x minus 1 squared plus 4. So, and I'm going to kind of jot my stuff, and then I'm going to start to build my graph kind of right down over here. So Number one, I want to know whether or not it opens up or down. So we've got this negative right out here in the front. Since that is negative, I know that this opens down. Now that doesn't help me any right now at the current moment. I just know that when I start to put dots, I should see them going kind of in a downhill shape as opposed to an uphill shape, okay? So second thing is I want to know where my vertex is. So if I look, I know that my vertex, remember that inside the parentheses does the opposite. So -1 is actually going to go to the right 1. So I'm going to go right 1 and then +4, not in a set of parentheses. So it's going to do exactly what we think. It's going to go up 4. So I'm going to go 1, 2, 3, 4. And I'm going to plot that dot. And then I can come back and state that my vertex is at 1, 4. Now, for the next thing, I want to find my x-intercepts. So we're going to take and set our equation equal to 0. And now we're going to work on solving. So very much when we were working on inverses and stuff like that, we're going to start peeling these layers away. So the first thing I'm going to do is subtract my 4. Now, I don't want to make this harder or more complicated. So the next thing I'm going to do is divide by -1 so that I can cancel that off. Now I want to get rid of the square. So we're going to introduce a square root. Now, we have talked about that when we introduce the square root, we need to introduce a plus and a minus. So now I'm going to have x minus 1 equals, now I can do the square root of 4, it's 2. And so I'm going to have it equals 2 and -2. So I handle both the positive and the negative. I'm going to finish by adding 1. So I've got x equals 3. So I'm going to go add that spot on my graph right there. I'm going to add 1 here. It's going to give me -1. So I'm going to go add that dot over here. Now, one of the things that I want to go ahead and make mention of, we talked about that there is an axis of symmetry here. So I'm going to go ahead and draw that axis in, knowing that the axis of symmetry does go straight through that vertex. Okay. And one of the things to note here is that because it is an axis of symmetry, I should have mirror match points. So notice this x-intercept is 1, 2 units to the right of our axis of symmetry, and 1, 2 units to the right is the other x-intercept. So we do have them both equally matched. Now I'm going to use that axis of symmetry thing here also in just a second to help get me a couple of an additional point that will help me out. So for my y-intercept, I'm going to plug in 0 and I'm going to solve. So 0 minus 1 is -1. So I've got -1. Okay, so -1 squared is +1. So I've got -1 plus 4 is going to be 3. So I'm going to go ahead and put that dot in right here. Now, what I can do, and this is not a point that I'm doing math for to do, but because this point is located 1 to the left of our axis of symmetry, if I go 1 to the right of our axis of symmetry, then I will gain an additional point on my graph. And again, I did that one kind of as a star so that you understand I didn't do any math behind it. I'm just utilizing the fact that I have an axis of symmetry and I have to have that nice mirror matching stuff. Now, traditionally with quadratics, you want anywhere from 3 to 5 points to be able to graph them. You don't want them all on one side. So in this case, I've got enough. Even if I just had the 4, I have enough because I know this has to be the top right here, vertex. So I'm going to make a nice, pretty U-shaped graph. Okay. One of the things that I see done most often is people want a really kind of sharp corner right there at that vertex. And so here is our lovely shape. We have a nice U shape. It opens down, so it matches what we had said at the beginning. We've got our vertex, our x-intercepts, our y-intercept, and we were able to gain that additional point of symmetry.